Introduction to normal distributions and the standard normal distribution. We know that the continuous random variable and the continuous probability distribution. Continuous random variables, we know what is a random variable. A variable which will hold the different types of values, which is constantly changing. If that constantly changing value is a continuous value, then it will become the continuous random variable. Okay, the number of hours spent studying on one particular subject can be said as continuous random variable. Continuous probability distribution. The probability distribution of a continuous random variable can be considered as a continuous probability distribution. Okay, we know what exactly the normal distribution is. Okay, the total area of the normal distribution is always considered as 1. Guys, this session, okay, I will just cover a very short. Tomorrow we will get in deep or in depth. Otherwise I can say I will just go a little bit, I will cover a lot. Okay, maybe I may complete this presentation tomorrow. Okay, so what I request you is to concentrate more, okay, today and tomorrow. So here the mean, median, more or equal, we know that, and the normal curve is bell-shaped curve and symmetric about the mean. Okay, the total area under the curve is equal to 1. The normal curve approaches when, see here, you can see this tails on the left hand side and the right hand side. The normal curve approaches but never touches the x-axis as it extends farther and farther away from the mean. You see, we will never show them it is touching the x-axis, okay, but still the area comes to the something like this. The total area within the curve can be considered as 1. Okay, so and also we already discussed that mu, which is separated by a standard deviation on either on the negative x-axis or the positive x-axis. Generally these are all called the inflection points. Okay, you can take a look at this one, mean and standard deviations. A normal distribution can have any mean and any standard deviation. The mean, which gives the location of the line of symmetry. If you can take a look at this one, you can see these are the inflection points. The mean is same for both of these two curves, but this is the spreaded curve, more spreaded curve, and this is a little bit leaner curve. Okay, but what is the main difference that you can observe? Standard deviation. The more standard deviation, the more spread the data. Which curve has the greater mean? Obviously, A will have the greater mean. Which curve has the greater standard deviation? Obviously, it is B. Why? Because it is more spread. Okay. The heights of a fully grown white oak trees are normally distributed. The curve represents the distribution. What is the mean height of a fully grown white oak tree? Estimate the standard deviation. Okay, by looking at this curve, we can clearly understand that the mean of this particular uh, graph is 90, and whereas the inflection, coming to the inflection points, it is 3.5. It's the standard deviation. Okay, the standard normal distribution. Till now, so far we have discussed about the normal distribution. Today, I'm just introducing you something called a standard normal distribution. The standard normal distribution, how exactly it is different from the normal distribution. Look, a normal distribution with a mean of 0 and a standard deviation of 1 can be called always it as standard normal distribution. The area of this entire curve can be considered as 1, and the axis looks something like this. It will start with the minus 3.49 till plus 3.49. It has a mean is equal to median is equal to mode is equal to 0, and which is separated by a standard deviation of 1, okay, where you can observe that in the x-axis. So in order to identify the x value, okay, and also you can make it transfer transformed into a Z score. Z, this is generally what we call it as Z distribution. Z distribution. See, x is equal to Z is equal to x minus mu divided by sigma. Okay. So we might have a confusion. What is the normal distribution and what is standard normal? See, standard normal distribution, it was created in such a case like to generalize the normal distribution. Why? Because in the normal distribution, you might be having a different values of mu and different values of the sigma. When we are correlating that one to 0 and 1, and then we calculate the rest of the values and we will come back to our normal distribution score. So if each data value of a normally distributed random variable x is transformed into a Z score, the result will be standard normal distribution. Remember this one, this is very important. Okay. When we are comparing each and every value of the normally distributed random variable x, which is transforming into a Z score, the result will be the standard normal distribution. The cumulative area is close to 0. You can see the cumulative area is close to 0 for Z scores, close to minus 3.4. I already told you this last. When we are starting from the left end, the area represents 0. When you are traveling towards the positive end, the area keeps on increasing and it will reach to 100% on the other end. Okay. If someone asks you what is the cumulative area for the Z is equal to 0 in the standard normal distribution, it is 0.50 is the cumulative area. Why? Because the total area can be considered as 1. The cumulative area is close to 1 for the Z scores, close to 3.49. Okay, this is generally a cumulative area chart, standard normal distribution chart. Find the cumulative area that corresponds to a Z score of 1.15. How do we check this one? In the table, you need to verify the 1.1 on which is on the y-axis, or otherwise it's a vertical column. And whereas on the horizontal x-axis, you have to identify the 0.05. 1.1 plus 0.05 will become the 1.15. You need to verify the output value over there. So that value will become the exact Z score value. This is how that you will identify the Z score in a one particular problem statement. Understood this one, everyone? Huh? All of you. Take a look at this one. Sketch the standard normal curve and share the appropriate area under the curve. Find the area by following the directions for the each case shown. To find the area to the left of the Z score, to the left of the Z, find the area that corresponds to Z in the standard normal table. See, the area to the left of Z is equal to 1.23. See, when you are trying to calculate the area behind the 1.23, you can see here in the before table, you can clearly see that 1.2 is this one, right or wrong? 1.23 we need. So 0.03 plus 1.2. How much it will become? 1.23, which is 80.89. 0.89 is none other than 89% of the area. So this is always nearly 89% of the area of the entire curve. Coming down here, if you wanted to identify the other piece, okay, or other half of the curve, it should be considered as 1 minus, okay, 0.8907, which will become nearly 10.9% of the area of the entire total curve. Understand? Okay. So if someone wants a middle stuff, generally what do? You can see only highlighted area requires to be done. Okay, we know we have already calculated for 1.23, and we know how to calculate it for 0.5 0.75. Why? Because in the same chart you will find the negative values also. Okay, zero point 0.7 and 0.05 will become 0.75 minus 0.75, and here you need to identify what is the value here, and you will take the 0.8907, which is a total area till 1.23, minus the value of the jet score that you are going to get it for the minus 0.75, which is 0.2266, and if you are going to make a subtraction, you will get the middle shaded area. Okay, all of you. Find the area under the standard normal curve to the left of z is equal to minus 0.99. Z is equal to 0.99, which is representing, which is close to the starting point. So hence the resultant percentage of the jet score or the area of the curve can be definitely be small. So which is a 16 percentage, 16.11 percentage, which is around 0.16. Okay, take a look at this one. Find the area under the standard normal curve to the right of 1.06. Right of 1.06, you will never get the right of 1.06, guys. Okay, you will never get it. So what you need to do, you need to first calculate to the left of the 1.06. 1.06, let us go ahead and check. One, this is not the one, so take a look at this one. 1.0, okay, 1.06 means you have to go here. Okay, which is 0.8554, right or wrong? 1.06 is 0.8554. So here what we need to do, 0.8554, you need to subtract it for the 1 from 1. Why? Because 1 is the total area of the entire probability distribution of this curve. So 1 minus 0.8554 will give you the rest of the remaining area of the curve, which is 14%, 14.46 percentage. Okay. So in the same way, we can always identify the area between the two different jet scores. Okay. Exactly, it will give us the left. It will give us the results from the left hand side. Why? Because it left hand side, it will start from the 0, right? The left extreme, I have already showed you. What is the left extreme here? Minus 3.49, where the area starts from 0 here. When you are traveling towards the positive end or the positive side, the area of the curve will keep on increasing. Okay, then once you go to the end of the curve, then it will become, the z score will become the 3.49, and the area will become close to 100%. And these are all the tables that you can get online. Okay, you can find the z score tables. Okay, you will find the z score calculators and all stuff, but manually checking the z scores will always give us some sort of understanding. Okay, instead of using the calculator. Why? Because we should know how do we calculate this, how to calculate this. Okay, so finding probabilities, we will see this finding the probability stuff tomorrow. Okay, before I'm going to start the tomorrow session, I will ask you. Okay, I will ask you some, I will just make you to practice on this jet score, identifying the jet score by giving you some values. Okay, so, and also I just wanted to make you make you to search this jet score table. See, jet distribution table. If you click on this one, you can always identify many images of this stuff. Look, jet score table. If you come down nearly, you will get the scores from the negative till positive. Huh? You got it? Otherwise, you can go to the z-table.com, which will give you the values of the corresponding stuff. Okay, just go for the table, that's it. You are not required to study anything else apart from that. Okay, you will see the positive entries and the negative entries. So you can take down anything else based on your requirement. Okay, so are we ready to solve some problems in the tomorrow session based upon this one? Okay, I'm going to end up the session for today. Okay, I will take some time in order to send you all whatever that I promised you today. I already have your email addresses. Let me just take a look of that. I think recently I have shared you something, right? Okay, in the same way I will send you the material. Okay, we'll see you again tomorrow. Hmm? Have a nice day. See you all tomorrow. Bye.